configurations, come in and ask questions. After you've practiced electron configurations long enough, you'll get very annoyed with writing 1s2, 2s2, 2p6, because every element that has more than 10 electrons has 1s2, 2s2, 2p6. What you've been working on writing is something called the complete electron configuration. There's also something called the noble gas configuration. And what the noble gas configuration does is makes it so you don't have to write out all the 1s2, 2s2, 2p6. You group those, and then you write the electron configuration that exists beyond that grouping that you give. So the shortcut is that you put a noble gas into a bracket. What's a noble gas? A noble gas is the last column of your periodic table that includes the helium and neon and krypton and xenon, all those ones. Okay, those are your noble gases. And what you do is you put the noble gas that existed before your element in a bracket, and then you write the electron configuration that exists after that noble gas up to the element you're working on. So let me do an example for you guys so you see how this works. Okay. If you want to do the noble gas electron configuration for nitrogen, you find nitrogen on your periodic table, and then you go back and up to the noble gas that exists before nitrogen, which is helium, and you put that in a bracket. And then you list all the electron configuration that happens after helium. By putting helium in a bracket, what you're saying is, my electron configuration has everything helium has. So helium has that 1s2. You're not writing the 1s2. You're putting helium in a bracket. So what you need to write is what exists beyond helium that nitrogen has that helium does not have. So let's do another one. If I was going to do the noble gas configuration for tin, I would find tin on my periodic table. Okay, tin is 50. And then I would go back and up to the noble gas that exists before tin. So I have to find a noble gas that has an atomic number smaller than 50. Okay, the closest noble gas that's smaller than 50 is krypton, which has 36. So I would write krypton in a bracket. That's again saying my tin has the same 36 electrons as krypton. 1s2, 2s2, 2p6, 3s2. That's all included in this bracket. Now all I have to list is what tin has beyond krypton. I have to list those 14 electrons that exist between 36 and 50. So you don't start at 1s2 because the 1s2 is part of krypton. Instead, take a look at where tin is, and tin's in row 5. So your first electrons beyond krypton are in 5s2 for tin. So that's 2 of them. And then the next comes 4d10 for tin. And then tin has 2 electrons in 5p. Okay. Those are the 14 electrons then for tin that exists beyond krypton. Essentially what you've done here is said all of this is summed up in krypton. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. That's all krypton's electron configuration. I don't need to write that part of tin's. Okay. Tin goes beyond 4p6 though to 5s2, 4d10, 5p2, and that's what you have to write. Okay. The reason these are the ones that we have to report are these are the ones that end up doing the bonding. This is how we shorten our electron configuration. We just focus on the electrons that are actually going to be doing stuff. These are usually called the core electrons, and these are the valence electrons. Okay, these are the ones that are going to be stationary and don't do things, and these are the ones that actually do chemical reactions. So if you were going to do sodium, sodium has 11 electrons. So you find a noble gas that's the closest to it that's less than 11, and if I look on here, I see, oh, I have neon, and neon's just 10. So neon has the first 10 electrons of sodium summed up right here. Which means all you need to do is list the 1 electron for sodium that's beyond neon. And that is the 3s1 electron. How did I know it would be 3s1, not 4 or 5? I just looked at where sodium was. Sodium's in row 3 in the S block, so that's where I start. We can do vanadium. Vanadium has 23 electrons. So I go back and I find the closest noble gas to vanadium that has less than 23 electrons, which is argon. And I just list the electrons that vanadium has beyond argon, so 19 through 23. Those electrons start at 4s2, and then we go 3d3. And those are the 5 electrons that vanadium has beyond argon. And that's all I have to write. That's all I have to write. It's way shorter and a lot easier for most people.